Good morning, everyone. Welcome. I hope you're sitting comfortably. Welcome to the first in a new series of Breakfast with Arup seminars. We're online only at the moment, so I hope you've got your own breakfast arrangements sorted out. This is the first of a series of 6 seminars that we'll be putting forward over the next 6 months or so, exploring the theme of net zero carbon. And we're very much hoping that during that series we will be able to welcome you into our shiny new offices and actually provide you with some breakfast as well. So for this first seminar, we're joined by colleagues from Alinea, and we'll be exploring the issues raised in our joint article in last December's Building magazine. And so it gives me great pleasure to introduce our chairperson for the first session, Thomas Lane from Building magazine.
Good morning, everybody. Just by way of introduction, I look after the section of the magazine where the article appeared, and I'll be chairing today's session. The pressure is on to cut carbon emissions from new office buildings. Investors want to put their money into businesses, which include developers as well, with strong environmental and social governance. This is translating into high demand for net zero offices from ESG aware corporates and also to future-proof property portfolios. Breaking away from conventional approaches to design and construction generally comes at increased cost. There are already enough cost pressures, including materials price inflation and skills shortages, so the pressure is on to find ways of delivering net zero office space for minimal increased cost. Alinea and Arup collaborated on a piece of research at the end of last year, which, as we said, was published in Building. This examined how the carbon impacts of a typical mid-rise office in Greater London could be reduced for minimal cost uplift. They proved this could be done. Today, we will hear from the team who did that research, and you will also have the opportunity to ask some questions too. So our expert panel is Stephen Hill, who you've already heard from, who is an Associate Director Building Performance Team in London. Stephen specialises in sustainable carbon strategy for buildings and portfolios, both during development and in operation. Matt Collinson is a colleague, also a director at Arup, who works as part of a multidisciplinary team in their London office. Matt is an engineer with particular interest in helping clients develop net zero buildings. Rhona Sampson is a mechanical services engineer at Arup with experience in sustainable building services and construction. And from Alinea, we have Steve Watts, who is a partner and the chair of the Council on Tall Buildings and Urban Habitat. Steve is a regular contributor to Building Magazine's economics section. And finally, we have Tom Atkinson, who is an associate at Alinea, who is leading their carbon initiative. So today's format, we will have presentations from Steve, Rhona, Tom, and Stephen as well. And then there will be the opportunity for you to ask questions. So once there is a chat function you'll see in your browser. So if you want to ask a question, just type it into that box, and we'll endeavour to answer as many questions as possible. So without further ado, I'll hand over to our first presenter, who is Steve Watts, who is going to give a commercial overview of the move towards net zero, including some of the challenges. So over to you, Steve.
Thank you, Tom. Good morning, everyone. And I guess my job this morning is to provide a little bit of gentle context, which will lead into others on the call providing a little bit more detail that was included in that bit of research that was published that Tom just mentioned. And I guess the first thing to say, next please, is that we're clearly past the age of indifference, but we're on a journey, and that was something that was brought into sharp focus by the promises that were made in Glasgow at COP26, which are insufficient to meet the goal of limiting global warming to 1.5 degrees. So the pressure is on, as Tom actually mentioned earlier, and that the buzzword at the moment is implementation, and people are saying that means the real and measurable efforts to achieve net zero. And those two words, I think, are very key to me and provide both the challenge and the opportunity at both a global level and at project level in our industry. And I guess those challenges begin with some slippery terminology, because I've seen various phrases used, not just net zero, but carbon neutral, zero emissions, carbon negative. I personally am not sure if all of those mean the same things. And it was very interesting that I had a chat with a very young, bright daughter of a friend who's a fund manager whose job is actually titled Responsible Investment Analyst, who spends a whole day looking at funds to assess their ESG credentials, who said, you know, it really, there is a lot of opportunity for greenwashing in all of this, but regulations are tightening and there is increasing pressure on proper disclosure. So she was quite positive about what was going to happen in terms of encouraging firms and nations even to be more transparent in their endeavours. Next, please. And I guess striving for net zero is not only the right thing to do, clearly, but it has a monetary value as well. This is one of many graphs I could have shown that demonstrates that ESG investment is booming, and there's actually a boom in green tech venture capital too. And as I said, funds are being increasingly assessed for their ESG credentials, and that's become a whole industry in itself. But not only that, developers are telling us that sustainable buildings definitely have a higher capital and rental value too. So there's both, you could say there's both a non-cynical and cynical reasons for developers to create more sustainable buildings. Next, please. There's no doubt that commercial property's biggest problem now is no longer the pandemic. It's the well-known fact that buildings and construction contribute 40% of global CO2 emissions, and investors and developers are acutely aware that if they don't address that, their buildings risk becoming obsolete or even unusable, and that applies to existing assets as much as it does to potential new developments. And the first question we've got to ask on every potential new development is, does there have to be redevelopment, or can we retain and use as much of the existing building as possible? And this article here was actually in the FT last year, which put that point into very sharp focus, even saying that demolition was architecture's dirty little secret. Now, the difficulty is that when you're looking at options, the absolute key is to ensure that even if you're retaining the existing building, it's not so compromised that it fails to deliver something which is sustainable in the long term. And sometimes that's possible and sometimes it isn't possible, which means that actually making new office developments, say, not only net zero, but net zero at the lowest possible cost is absolutely critical, which is the whole point of this article. Next, please. And there's absolutely no doubt that attitudes have changed at project level. You know, the old golden triangle of cost, time and money that us QSs absolutely loved has become a 4-point diagram. I use a pyramid to show carbon as the fourth parameter, and that fourth parameter is of equal importance, if not more importance on some projects than the other three. And there are even examples I'm beginning to see of main contractors being asked to contractually commit to projects' carbon objectives, and they're just in the process of considering how they do that. Next, please. And this is sort of a very simple diagram, not through that, which is just trying to show that, you know, even in that old 3-point eternal triangle that I referred to in the last slide, there are always inherent tensions between those three objectives. You can't get the best time, cost and quality, and obviously carbon is now a fourth dimension, which introduces yet another tension. But not only that, there are even tensions within the carbon objective, not least because if you're trying to achieve both short-term and long-term gains, i.e. reducing both your embodied and your operational carbon, more often than not, you can't, it's a case of best fit between those two. Sometimes there'll be a trade-off between one and the other. That said, often, as with cost and carbon, it might be more difficult to accurately assess the long-term estimates of those two things, but the impacts are even greater. So it's important that they receive equal focus. Next, please. And as we begin to consider that, that's before we even think about the wider considerations of ESG. Going back to that conversation with the fund manager, it's not simply about carbon. And social value is a term which is used to describe those wider things. And we have projects where we're thinking about social value. It's not just about reducing both embodied and operational carbon. It's about the wider implications on a community that a project has. Next, please. And at Alinea, we're very aware of current challenges, and I've put these into 3 categories here. The first is that, I mentioned there's some slippery terminology at the highest level in terms of net zero carbon. That happens at a project level too, and I still see, both upfront and embodied carbon, for example, being used interchangeably. But the key one for me is the basis of methodology of carbon assessments, and maybe what a lot of people don't realise. I mean, this is less about the fact that there are different software platforms that are used, and more about the fact that there's an unawareness of the level of allowances which go into carbon assessments. In the same way, there's a level of allowances which go into cost plans. A stage 2 cost plan will have something of like 40% of its cost related to unquantified elements, and the same will apply to carbon assessments, and they will have a similar level of contingency at early level. There's absolutely nothing wrong with that, but I guess where we need to be careful is that carbon estimates at an early stage of a project are maybe seemingly more accurate than the actual basis that they're used, and we just need to be aware of that. Next and final slide, please. And if all that sounds a little negative, it's not supposed to be, because as I say, we're on a journey. This is a relatively new discipline. We're learning, and we'll crack it. And whilst we are progressing all of those challenges, for us, the absolute key is to prioritise the right things, and that must start with looking at design interventions which reduce material from the building. Because if you reduce material, it's a positive double whammy of reducing both cost and carbon, and there are ways that can be done. I know we haven't got any structural engineers on the panel, but for us, looking at the efficiency of the structural frame is a really good starting point. It's not the only element of building where that approach can be applied, but it's a really good one. That, alongside challenging the old brief, those 2 things alone will give us a long way to actually achieving net zero, but at a pretty good premium as far as we're concerned. And that is my context before I lead into others to perhaps provide a little bit more detail as to how we think that might be done related to the article. Thank you.
Thanks very much, Steve, for that. So we'll move on to our next presentation now. Rhona Sampson is going to examine the technicality of the net zero challenge and how these might be overcome. Thank you, Rhona.
Thanks very much, Tom. So I'm going to lead us through a quick review of how the buildings of today are responding to the challenge of net zero. Next slide, please. So the 8 images on this slide are all Arup buildings, or buildings where Arup are evaluating the whole life carbon. So we start from the sort of buildings on the left, which are now either entering construction phase or sort of significantly progressed towards construction phase. And these buildings perhaps started the design process 2 to 3 years ago, and a net zero aspiration has perhaps been introduced partway through the design process. And we've worked within the context of an original brief to refine a design towards net zero carbon. Then as we kind of move across the slide towards the buildings on the right, these are buildings where we've had the opportunity to incorporate net zero and whole life carbon aspirations at an early stage within the design, or incorporate it into the brief. And I just invite everyone to sort of look at the similarities, or perhaps the lack of dissimilarities between the 2 sets of images. Next slide, please. The following 2 slides look at how progress towards net zero can be achieved within the limitations of today's built environment context. That is, considering the impact of current tenant behaviour and expectations, and cost of effective technology and products available to us. So this is the operational energy graph. On the left hand side, we can see the kind of current REEB good practice evaluation of good operational carbon. This is typical performance of buildings which may have been designed 5 to 10 years ago and currently operational. As we step through the purple bars, towards the centre of the graph, these show the measures that we're typically already delivering to achieve cost-effective buildings that are performing well on operational carbon. So all electric strategies, efficient systems, optimized facades, etc. The next sort of major intervention that we see is actually in relation to the tenant behaviour, and we have this sort of blue bar in the centre saying low carbon tenant. That's somebody that we might define as using less small power than a conventional tenant, or somebody who turns off their HVAC systems when they're not occupying the office. That, as you can see from the graph, makes a significant reduction in the operational energy and carbon emissions, both annually and obviously across the building life cycle. And that can sort of take us further sort of below the kind of sort of 46% over notional Part L carbon reductions that we would sort of steer us towards a NABERS 6-star rating. As we move across the graph, the kind of bars on the right show marginal gains that can get us towards NABERS 6 stars. So picking up on a point Steve made, for this purpose, or the purposes of this discussion, we're kind of describing operational net zero as being a NABERS 6-star rating. So as we kind of move across towards that target, these are things we're learning about as we explore sort of design and optimization and building operation. And the majority of these are about monitoring and close control of systems, particularly fresh air and ventilation, to extract the maximum possible energy savings from HVAC while still delivering a comfortable and marketable building. I think the major takeaway from this slide is sort of most of the or many of the interventions on the right hand side are sort of delivered through a kind of Cat B tenant fit out or Cat B level. So incentivizing tenants to operate the building sustainably and looking at how we can influence our Cat B fit outs perhaps beyond a Cat A brief is going to be crucial in achieving our sort of net zero operational targets. Next slide, please. So this is the embodied carbon version of that same graph, and on the left hand side we can see the sort of current good practice benchmark, which is the GLA embodied carbon. That corresponds to a LETI F rating, and we're moving across the graph to a LETI B rating on the right hand side, which again, for the purposes of this discussion, we're kind of categorizing as net zero. As we move through the left hand side of the graph, through the red bars, we see some of the interventions that we may typically be using between or in current building designs or have an aspiration to use. The most significant of this, you will notice, is the removing a basement and lean structural design, as well as beginning to think sort of towards the centre of the graph about cement replacement and designing out transfer structures. So reducing that material for a double incentive of cost and carbon reduction. On the right hand side, we're looking first, our big win there is more sort of radical structural solutions, designing thinner slabs, new column types and different grids. All of these interventions potentially impact things like column densities, floor to floor height, servicing coordination, and of course construction program and techniques. And these can have a significant impact on sort of our brief for buildings as we move towards kind of net zero embodied. We then move into recycling and reclamation of materials, and then sort of trimming the marginal gains towards the right hand side, reducing carbon content of specific elements such as glazing, steel profiles, and removing suspended ceilings. Next slide, please. If you begin to kind of link together the measures on the sort of right hand side of the graphs as we sort of push towards or take more stringent measures towards achieving a real net zero goal, you can kind of see the differences potentially in the office environment emerging. So this render is from a sort of current, perhaps best in class office designed with a lean but not necessarily a net zero brief, and can maybe be thought of as a sort of conventional office product today. You can't see it, but let's assume that we have a structural, a lean structural grid minimizing steel weight. We still have concrete columns with a typical column density befitting the structural solution. And this particular building has a fan coil driven active HVAC solution with heating and cooling from an all electric heat pump, and all of which is kind of concealed above a suspended ceiling. If we go on to the next slide. This shows a render from a project which is kind of still very much on the drawing board, kind of early mid-stage design. And you can see that the visual has changed significantly. So here we are looking at new column designs, which sort of take weight off the structure without compromising grids. The suspended ceiling has been removed. And instead we have a sort of passive HVAC strategy rather than typical fan coils with exposed chilled mats, which are made viable both by perhaps a relaxation in comfort parameters and internal gains, but also by a sort of more sophisticated control system, which uses sort of sensor-based inputs to monitor and control fresh air supply volume, make use of free cooling, and monitor space temperature and humidity. So as we kind of look at these two options and as we sort of continue to kind of explore what the next iteration of the office might look like, I'm keen that we kind of ask how we can further challenge our design briefs, our tenants, and sort of carbon assessment methodologies to facilitate the next steps towards a meaningfully net zero building. Thank you.
Great, thanks very much, Rhona. So we're now going to move on to a presentation from Alinea. Tom Atkinson is going to consider some design interventions, including the cost and the carbon impacts. So over to you, Tom.
Thank you, Thomas. Good morning. I'm going to briefly talk about some of the commercial impacts of the design interventions that can help lead to a low carbon solution. Next slide, please. In the article, we touch on low carbon design considerations, and ultimately, what do we mean by this? Rhona's talked about it in the previous slides, but ultimately we're trying to achieve an outcome that has the lowest amount of carbon but achieves the same output and does not detract from the overall project goals. The way we can manage this in practice is to allocate our overall carbon target that we set in accordance with our project aspirations on an elemental basis. We can then look at design options that save carbon married with their impact on cost in a cost-benefit scenario. And one of the things we demonstrate in the article is that by rationalising some design choices from an embodied carbon point of view, allowing our requirements for, say, column-free spaces to relax, enables grids to become more efficient, and in turn reduces the amount of weight in them, less material, less cost, and therefore lower carbon. A number of carbon reducing measures can be associated with not doing something, and that certainly is the case with basements, frame, upper floors, and finishes, such as ceilings in offices. That said, specification tweaks, new technologies play their part. GGBS in concrete, for example, and even earth-friendly concrete have a further impact at relatively low comparative cost. Conversely, as Steve mentioned earlier, the interventions to the right here relating to operational carbon, whilst increasing overall cost of the building in this scenario, can be offset by the context that they contribute to an overall reduction in whole life carbon across the service life of the building. So running through lean design principles enables an already carbon efficient version of itself. Next slide, please. So what I've done is I've just pulled some embodied carbon examples out of the article in isolation to show clearly the cost benefit approach. And as you can see, by simply stepping back and looking at the design, asking ourselves whether it's worth accepting a more efficient grid, will it really detract from the end experience? Are occupiers happy to accept concessions if it means a reduction in whole life carbon? But actually, these three interventions result in a 17% reduction in embodied carbon and a 1% reduction in overall pounds per square foot on the GIA for the cost of the building. So in this example, a supremely optimum result. Next slide, please. If we take the baseline a bit further and start to consider more deviation from our traditional BCO office plate, we can reduce embodied carbon further, again by extracting a few examples from the article. Specification tweaks provide more options. However, it is important to note that more aggressive interventions have wider impacts. I've highlighted in this example ceilings, which is a great example of not doing something and therefore the perception of saving embodied carbon. However, as we know, not having ceilings often requires the introduction of acoustic and fire considerations and services to be laid out in a more aesthetic manner. Conversely, not having a ceiling can result in a greater cost on the overall pounds per square foot. So in a cost benefit scenario, it's not always something that we want to consider. In a similar way, and an option we've excluded from the article, was the adoption of CLT and glulam. Whilst drastically reducing carbon in the frame, the nuances of acoustic and vibration and fire treatment often add additional cost and additional carbon. When we look at more aggressive measures such as CLT and glulam, it no longer becomes about swapping out one material for another, but in turn how the asset is occupied and how it is valued. Sticking with timber for a second, slab and beam depths often need to be deeper than traditional materials, and therefore a number of floors in the building may need to reduce without affecting the building height. The building therefore becomes less efficient from an NIA perspective. And this is often, similar in the case of basements. Omit the basement, okay, but then mechanical and electrical equipment still needs to go somewhere. Unless we change the occupier buildings, something that Stephen will talk about later, then we need to reevaluate how we look at our assets. So embodied carbon reduction in our projects needs to be carefully considered, and hence the need to get the project brief clearly set and the cost and carbon aligned so that design interventions can be considered on an informed basis. We often get the question as QSs, what is the cost of net zero? And unless you're constructing the same building time after time, it's actually a very complex question. And the answer is, it really depends. It depends on how net zero you want to be. What carbon targets have you set? And has your brief developed such that it can accommodate a net zero offering rather than trying to produce the exact same product without any carbon implications? Next slide, please. My final slide is something I touched on briefly in the article, and that's the importance of adopting a carbon contingency, or perhaps a range at early design stages. This is a table I've taken from a publication called Improving Consistency in Whole Life Carbon Assessment and Reporting, which was written by the Whole Life Carbon Network, Letty and Reba. I've added a contingency column along the side here to demonstrate some deviations from initial targets I have observed through moving through the Reba stages, and that is to account for the fact that a number of stage 2 cost plans, or even later stages, are simply not quantified to that degree at that stage of the project. Similarly, how cost models are developed. At the early design stages, carbon models make a number of assumptions. Across the board, what EPDs do we align ourselves with for every material in the building? Where does that material come from? Will it be available at the time we come to build? With new technologies, is it tried and tested? How is the market geared up to respond to demand? How much of it do we have? And this is a key one for us as QSs, because as I said, at feasibility design stages, we generally use generic values to determine cost models. Carbon assessments need to follow the same principles. We won't know exactly how much of a specific material, steel or concrete, for example, will be in the structure until we get to the later design stages where the design is fully coordinated. Therefore, we need to assume that there is going to be a degree of deviation from our assumptions from the base design. As you see in the table here, like a cost model, the assessment needs to be made on generic quantities initially, through to actual values in the construction phase. Carbon targets cannot simply be applied at the end of a design stage if the implications have not been picked up throughout. Therefore, the contractor cannot pick up the slack at the end, not least without some serious design changes and a redesign period. Carbon targets are ambitious, but we shouldn't use them to back ourselves into a corner, but rather try and make the most informed decision about what is best for the project so that we are consistent with our industry reporting, and that in turn will benefit everyone. That's it from me, Thomas.
Great, thanks very much, Tom. And we're now going to move on to our last presentation before we start a discussion and take some of your questions. Stephen Hill is going to cover the NABERS energy rating scheme and provide an overview of what is required to achieve a 6-star rating. Thank you, Stephen.
Thanks very much, Tom. So we've heard from Rhona and from Tom at Alinea about how we're managing to work our way towards net zero carbon through clever design and pursuit of marginal gains. In this final presentation, I question whether that's enough, or whether we need to be more radical if we're going to create buildings that are naturally net zero. And I think it's very important to remember that we're on the early stages of this journey towards net zero. All the buildings that are working their way towards net zero exist only on paper. Some of them are in the early stages of construction. And I'm not sure yet as an industry we've kind of grasped the extent of the tension between the net zero carbon performance that tenants and investors are starting to ask for, and the expectations of a tenant in terms of the service level that a commercial office provides. Next slide. No, that's fine. Sorry. Oh, you can stick. That's all right. Stick on that one a second. So we've seen how we can achieve net zero on paper through a lean approach to design, tight brief, pursuing marginal efficiency gains on a fundamentally conventional product. Next one. We're getting much better at optimizing structures, pursuing lowest carbon materials, as we've heard. The debate is raging about tightening up small power allowances, changes to occupancy density. We're starting to understand the impact of basements and the extent of back of house provision on whole life carbon performance. And overall, as a result, the buildings we're producing now are much better optimised for carbon impact than they were even 2 or 3 years ago. But net zero carbon on paper is certainly not the same as net zero carbon in reality. And I remain concerned that the buildings currently on the drawing board in the final analysis may still not do what they say on the tin. Next slide. This is where I think we are now, as an analogy, if you like. We're looking at leaner, all-electric versions of essentially business as usual, so that we haven't moved very far from the conventional product. We've changed the way that we produce it. Next slide. This is what I mean when I talk about naturally net zero. So yes, it's all electric, but it's a fundamentally different kind of product that prompts us to behave in a fundamentally different way. And I believe actually it's the behaviour of the people in the building that's as important as the performance of the building itself. Next slide. So naturally net zero buildings need to be lean. As we've heard, we're getting quite good at designing lean buildings now, but they also need to be bold and they need to move further away from convention. Next slide. So I've got just a few examples of some of the components that I think are an important part of a naturally net zero building. So passive systems is the first. So moving away from the market reliance on fan coil units to either chilled slabs, chilled beams. And I think this is a fundamental part of a naturally net zero building, because passive systems by definition limit the cooling capacity available. So the low energy performance of the building is effectively baked in. It can't be undone by a tenant wanting to operate the building in a particular way. Radiant cooling also improves comfort over a wider range of temperatures. So it allows us to be more relaxed in our internal temperature control. And whilst passive systems aren't common in the market, there are commercial examples. The one on the screen here is 2 Television Centre, one recent example. Next slide. Linked to the previous one, I think we need to be more relaxed in terms of our definitions of comfort for a naturally net zero building. We need to move away from the BCO standard 24 degrees in summer up to maybe 26, or even better, take an adaptive comfort approach so that the internal temperature is more directly tied to external. But this doesn't work if you've got a conventional office culture where people are wearing exactly the same clothes summer and winter. So people need to dress differently in summer in shorts, people need to wear jumpers in winter, much more actually like the way that we behave when we've been working at home for the last 2 years. So I think our challenge in terms of how we behave in the office is taking those behaviours over the last 2 years back into the office rather than reverting to more conventional practice that we were used to 3 or 4 years ago. Next slide. Natural ventilation is becoming more common in the market as we pursue these marginal gains, and it's definitely a key component of a naturally net zero building. But all too often what we see is a token gesture towards natural ventilation. Some opening windows, a strip of mixed road at the perimeter of a fundamentally fully air-conditioned building. What I think we need to do is deliver buildings where natural ventilation is at the core of the strategy. So our aim is to turn the main plant in the building off for significant periods of the year, and that's what really gives us the baked-in advantage. One of my favourite examples of this is the one on the screen. This is the GSW building in Berlin by Arup and Saarbrück-Hutton, which really embraced natural ventilation in the massing and the fundamental design of the building and its facade. And it's, as you can see, it's living proof that naturally net zero buildings don't need to be ugly. It's definitely an architectural icon in its area. Next slide. We also didn't need a different approach to materiality. So a great way to reduce embodied carbon is to remove whole categories of materials from the building. And this is interesting because it reduces embodied carbon, but it also creates a different look and feel. So it contributes to that idea that you're in a different kind of space, which prompts different kinds of behaviours. The image on the screen is Derwent's white collar factory in Old Street. And as well as a stripped back materiality, this has passive concrete core cooling, quite significant mixed mode. So this building, although it's, you know, it's 5 or 6 years old, is already in its concept is well on the way to being naturally net zero. Next slide. So naturally net zero is not actually rocket science, and there are examples, as I've shown, of all the components that go towards making it out there in the market already. But the key thing is we do need to be bold. We do need to take a step away from market norms, from the BCO definition of an office product. We need to be creating new kinds of buildings that can live up to the challenge of net zero carbon in design and in operation. And that's it from me. Thank you.
Great. Well, thanks so much, Stephen. So that is the end of all the formal presentations. So we can now move over and sort of discuss some of the points raised. So actually, I've got one to kick off with, which I thought was a really interesting question in Rhona's presentation, in fact, where we saw a big carbon saving from the elimination of a basement. Now, in areas like the city, I can imagine developers being pretty reluctant to get rid of a load of kind of valuable space where land values are very high. Steve, I mean, you're the kind of commercial man here. I mean, how do you think the development community is going to react to this? I mean, they've got to balance their net zero targets against, you know, hard commercial realities.
Yes, I mean, like I said, I think the key word in all of this is tension. There is always tension between conflicting aims, but the overall aim in this is to get the best fit across, you know, the whole life answer in both cost and carbon terms. We know from an embodied carbon perspective that if you combine the substructures and superstructure together, which is, you know, just two elements of the building, that together those represent 2/3 of the total embodied carbon footprint of the building. So, you know, removing the time, the cost, the risk, and the material of actually digging deep basements would make sense if you can make it work. But of course, the compromise there is, where do you put the stuff that would have gone down into the basement, and what impact does that have on the building above ground? Quite interestingly, we have one project in the office where actually I would say that compared to all other projects, it's probably invested the most time, effort, and money in making their building really sustainable. And I know every developer says they want their building to be most sustainable. These guys are really serious about it, and yet we're digging a very deep basement, which sounds counterintuitive, but the reason we're doing that is that it releases a lot of space above ground to create very generous terraces, lots of green spaces, large volumes for the well-being of the occupants. So, you know, that's a good example of where we're trying to find best fit between embodied carbon, operational carbon, and the well-being of the users of the building.
Right, that's really interesting. That's again, it's that tension, isn't there, between the sort of well-being aspects and the carbon ones. I mean, Rhona, I mean, are there any sort of technical solutions that could be adopted to, you know, you take up less basement space? I mean, more efficient plant. I mean, if you don't need boilers because you're getting rid of fossil fuels, does that liberate any space that you could cut your basement size down?
It's a really interesting question, Tom. I mean, I think, unfortunately, boilers were one of the pieces of sort of HVAC equipment that were quite well suited to being in a basement. And unfortunately, sort of heat pumps and chillers, although we typically do locate them there, plant size is probably increasing as we sort of try and achieve more efficient systems. I think something we've discussed about recently is the aspiration towards district heat networks. I know they're very controversial, and some of the existing ones in London, for example, are currently CHP led, which then throws a different angle onto the whole topic about, well, they are potentially not quite as low in carbon as a heat pump led solution, for example. But, connecting building systems simply into a kind of district heat network and removing kind of the need for plant in individual buildings could potentially be one way of resolving that tension.
Right.
But a big infrastructure investment.
Sure, I'm joined up thinking as well. I suppose you can do that on big estates. You've got, for example, Argent, it's King's Cross. I think they've got a centralised plant system, haven't they, where they can sort of do that. I'll move on to another question. Point raised by Stephen in his presentation about sort of sort of attitudes towards comfort conditions and dress codes in buildings. I mean, the question actually here is from Lee Stentiford, is asking whether the BCO will be updating their specification for offices to reflect the fact that actually maybe it is now time to relax comfort conditions in offices, because this is the Bible, isn't it, where everyone builds to a BCO spec. But if we could relax those parameters, we could cut a lot of carbon. Any thoughts on that from our panel?
Yeah, I'm happy to come in on that. So, yes, I mean, I think there is a challenge for the BCO, as there is for all of us, to work out how we better align the specification for a building with a net zero carbon outcome. And I think, the BCO last published in 2019, there's been a lot of water under the bridge, a lot of change, quite unprecedented rate of change since then. I know the BCO are looking at sending out some interim updates before the next scheduled main update of the guide. So I think the BCO is well aware that the market's moving rapidly, and they need to move as well to be a part of the solution, as opposed to kind of holding back and being part of the problem. I think they're well aware of that, and I think we can expect to see some kind of some updated guidance from the BCO quite soon. At least I hope so.
Right, that sounds very promising. Got a question here from John Spencer Hall, and it kind of relates a bit to the basement question. He's saying that he is finding that getting regulatory and planning regimes to sort of align with the net zero agenda is quite a challenge. So I guess an example would be if you're building a let's say, and I've seen this actually as an example, you're building an all timber structure, but you want to have a certain amount of space to make the scheme viable, and you need a basement. One option would be for the planning regime to relax a little bit on the net zero side and allow maybe another 1 or 2 floors height, so you can get rid of the basement. I mean, is that what is the panel's experience here of planning authorities, and do you think this could be a solution? Steve, you're smiling. Maybe you should take this one.
I knew it was dangerous to smile. Well, all I can say is I've yet to find an example of a planning authority relax their thoughts about the building form, and particularly the height above ground, to make the scheme more sustainable. That said, there's no doubt that the sustainability of the scheme is an increasingly important criteria in planning discussions and planning determination. So maybe that is something that will change, and maybe that's a hope.
Any other thoughts from the panel? I mean, does anyone here think that maybe there is a case to sort of allow us to go higher in certain height restricted areas? Obviously, you've got to allow for sort of planes flying into the London City Airport and all that.
I'm happy to pick up one more piece on that.
Thank you.
I think from what we're looking at in current projects is that we're starting to have some of those discussions with the planners, and there's perhaps a responsibility for us as designers and project teams to start to tell that story to planners, to kind of explain the reasoning and the objectives behind that. There are obviously restrictions, as you mentioned, with perhaps sightlines. But in terms of overall story for a project, I think there's definitely a case that we can put forward in that emphasis to really push the reasons why it is beneficial for perhaps to add a story to a building.
Right, absolutely. Another question here is a good one, really, because I've heard it said that if you really want to embrace net zero, you need to involve the project team early, so that everyone's involved and sort of working together collaboratively to come up with the right solutions. What the panel generally, I mean, what do you think is the optimal point when the main contractor and the supply chain should actually get involved in the project to really drive down that sort of carbon content in the building and also operationally? I guess this is the one here for maybe some of the designers, maybe Joanne as a structural engineer, or Rhona on the services side.
Matt, do you want to jump in? It looked like you were about to say something.
Thanks, Rhona. Yeah, I can partially answer that, Thompson. I'm sure Joe and Rhona have views as well. So I think it's kind of tempting to say the earlier the better, and I think that's almost true. I think we really want good partnerships with everyone. I think we need to be data driven as an industry, so making sure that we're ready to have the discussions at the right time with the right people. But kind of all expertise is welcome, isn't it? And we want to know early the impact of our big decisions, and how something will be built is a big part of that. How it will be used and maintained is another part of it. So I think Neighbours does help drive us down that path already. It's closing the gap between what we think and design and reality. And I think, yeah, it doesn't stop when we stop designing. Obviously, it has to be built and then operated and ultimately dismantled. And Stephen, I don't know, you might have something to add in terms of Neighbours on that.
Yes. Yes, I think early engagement is very important, because we've got to have a collaborative approach to setting the concept. You've got to get the brief right, you've got to get the concept right, and that kind of opens the door to success. But it's as important, I think, to think about what happens up to PC, at PC, and beyond PC as well. And I think we do need quite a fundamentally different approach. We've fallen into the trap as an industry of thinking the buildings are finished at practical completion, and that simply isn't the case. Certainly not in a building that hasn't even been fitted out. So that the contractor's role in commissioning needs to kind of move seamlessly into seasonal commissioning for probably a year after practical completion. And I firmly believe that the designer's role doesn't finish until the building is performing as intended, and it has been demonstrated to do so, whether that's through a Neighbours rating or another kind of process. So I think we need to think about getting involved earlier, but we need to think about staying involved longer. And in a speculative commercial environment, that does present some commercial challenges. There might even be a change of ownership in that period, but we're going to have to get used to a different way of delivering buildings and introducing them into the market, and a recognition that construction process doesn't really finish till 2 or maybe even 3 years after completion.
Right, thank you. Tom, I think you wanted to come in on the commercial side of for that question.
Yeah, thanks, Tom. I think from an embodied carbon point of view and a commercial point of view, there's some key aspects to consider with involving the supply chain, and some of those are: is the technology ready, and is it available, and is it ready and available to respond to the demand? GGBS is a great example. It's being used on the majority of new build projects across London now. Is there the supply there? Are we having to get that from sources that are actually far away? But then there's also the actual accounting part of carbon measurement. The supply chain is not always fully geared up to actually provide us with that data, and there's going to be a learning curve, as there has been on the more client side, for the subcontract side to actually come up and educate themselves and provide that level of quantity data that then backfills and informs the carbon measurement. This is particularly the case with MEP equipment, and I think everyone's quite widely aware of those challenges. So there is going to be a learning curve, and I think one of the pitfalls you could fall down into is when you're designing at an early stage is to select a product which, because of its low carbon credentials, make it all the way through the design process, and then find that actually to implement that product into the scheme, or actually to purchase it and get it to your site, is incredibly challenging, and the commercial aspect of that might not always be aligned with what you're designing at stage 2. So it's a difficult balance. As Stephen said, getting earliest is better is always nice to say, but yeah, it's a delicate balance, and I think with some of the more complex, newer technologies, it's important to get supply chain involvement earlier to make sure that supply can meet demand.
Okay, thank you. And I suppose as sort of implied in something in your response is, in terms of the whole life carbon calculations, who is responsible for this? I mean, is it the cost consultant sort of taking up that mantle, or do we need to have, if you like, a designated carbon champion on every project, and that person is the one who collates all the data and engages the supply chain in terms of the embodied carbon and materials?
I can come in on that one quickly.
Please do.
So we are definitely seeing the evolution of a life cycle carbon specialist role. I think, you know, that when we deliver that role, you know, it is our role to measure the embodied carbon, to work with the design team to work out what the optimizations are, and the people that are skilled in that are very knowledgeable in the detail and material specifications. We're starting to get a much better view in quite minute detail as to what good looks like in terms of steel weights, for example, but also, you know, going beyond structure, looking at you know, building services, which is a real challenge, and understanding how we strip carbon out of building services and architectural finishes and facades. So that is definitely a discipline that, you know, didn't really exist in any consistent sense across the market 2 or 3 years ago, but now, you know, most consultants have that service, and it is very much tied up with the way that the QSs work. And I think, you know, we're already working quite closely with the QSs. You know, we rely on QSs for all the quantities that inform those calculations, and I think, you know, opportunities for us and colleagues at Alinea and other organisations to find ways to kind of to overlap and make those roles much more efficient. But yeah, I mean, that is a discipline that's sort of grown out of nothing in the last 2 or 3 years.
Sure. Thanks, Stephen. Joanne, I've got a question here for you, actually. Is Lee Centford again is asking how we can be confident that that low carbon concrete, I mean, we're obviously familiar with GGBS and fly ash, but there are these new products coming on the market now that came to be zero carbon. How can we be confident that these materials perform in the long term, won't actually become a kind of a liability later on further down the line?
Thanks, Thomas. So I think, as you mentioned, GGBS and PFA, we're relatively familiar with that already. So there's a good body of buildings and research against cement replacements already. And I think one of the things that, again, we as an industry can do is ensure that when writing those specifications for projects, and that we are writing in that testing regime and ensuring that perhaps that body of research can build so that we get more and more information about it. So I think there is that potential to say, well, actually, let's look at the last 10 years, look at all of those buildings that have already started to incorporate some of those low carbon initiatives in terms of concrete specification, and do some of that testing, and then continue to build that body of evidence, and then we can adjust our specs as we go.
Great, thank you. I've got a question that everybody here might like to comment on. Xiang Sheng is asking, what is the real cost implication for a low carbon design? And, you know, I guess this is the nub of the subject, but you all got different perspectives on this subject. I'd be interested to hear what each of you think is actually the real cost implication. That's from the structural point of view, the MEP point of view, there's the commercial aspects as well. Steve, maybe you should kick off.
Okay, I'll let Tom talk about what we said in the article on that. and I will start by saying it's a wide spectrum. In the same way, you know, from my world of tall buildings, where people always perceive tall buildings to involve a large premium in cost, yes, they can, but also you can actually develop a tall building at low rise cost. And I think the same principle applies to carbon. And it's not just about carbon, by the way. So that that project I was talking about earlier, where actually there was a large investment in sustainability. Most of that investment is in the long-term operational and well-being aspects of the building. So if you just focused on that priority list I had earlier, where you're actually reducing material and creating a very efficient design, then actually the starting point there is a reduction in cost, isn't it? So it's therefore you're then adding on a series, a menu of potential enhancements. Now, some of those will be for operational carbon purposes, such as open all windows, which 3-4 years ago was probably the bane of QS's life, because it involves more cost, and potentially there's a redundancy in design because you involve a mixed mode ventilation system. But those sorts of things are being much more robustly challenged on an item by item basis. So I guess what that means to me is that, just to reinforce where I started this answer, is the premium need not be significant if you're focusing on the right things.
Right, thanks. And Tom, I mean, you crunched the numbers for the article, didn't you? What's your view on this?
Yeah, well, that question is very much the question we get. What is the cost? And unfortunately, it's not a straightforward answer because of the complexities. And we're talking about an asset that could potentially last 100+ years. So in the article, what we tried to do was take a baseline which represented a more typical traditional commercial offering in central London, and say, how do we get that to its most efficient position? And what we said in this scenario was actually the cost was relatively low in terms of the carbon reduction. In fact, I think we said it was £7 a foot on the GIA increase, which is a great result, because but you could take it further. Like I was saying, you could go further. You could look at CLT, and you could look at other new technologies, reducing the basement. That would get you so much further towards being true net zero. But then your service offering would be completely different. Your building would be less efficient. You'll be valued in a slightly different way. Perhaps there's a premium for those kind of buildings developing in London. But that's the short answer is, if you want to produce the same product with the lowest carbon possible, not that much of a premium, but it will only get you so far. If you want to get the truest net zero version you can, it is going to cost you a bit more, but the main cost is in how you value the building is going to change.
Right, thank you.
Yeah, happy to come in on that.
Yeah, please do.
Yeah, I mean, I think I completely agree with Tom. I think I think as we get better at this, we will find that actually a year or two ago we were looking at 8 to 10% cost premium. Now we're looking at sort of 2 to 3%. If you look at it in life cycle cost terms, I think there's a strong argument to say that actually these leaner net zero aligned buildings are actually lower cost over a whole life cycle. But I agree with Tom. I think it's not so much about the cost. I think it's about the value, and I think as we start to really understand actually what net zero means, and to be bolder in our response, it will be more about plot ratio, about how much space you can get on a site in the City of London if you're not delivering basements, if you're making buildings that are narrower plan so they're able to be naturally ventilated. And I think so there's definitely an issue about value creation and the constraints there. And then on the opportunity side, there's the real question about how is the market going to differentiate the value between a conventional building in inverted commas and a building that gets you to net zero carbon. And I think that's the real question that we're going to have to answer over the next sort of 3 to 5 years. What is it worth going to that, that bolder design in order to realise that longer term value, and what's the risk if you don't?
Right, thank you. Joanne, on the sort of, I guess you're looking at the structures, aren't you? I mean, what are the cost implications of net zero on the structural side?
So I think very quickly, from a structural perspective, one of the things we need to do is think beyond just material. So looking at what are the opportunities to still create the type of space that people are looking for with a super efficient structure, but also putting DFMA principles into that. So is there an opportunity for us to cost things, not just about the material, but also the way in which they're built, that gives additional benefits?
Right, thank you. And Rhona, on the servicing side.
I've been kind of sort of listening carefully to what everyone else is saying. I think I agree with Tom and Stephen that it doesn't, a low servicing, a passive servicing strategy doesn't necessarily have to attract a cost premium, although I'm conscious at the moment that sort of some of the products that we might want to use in a sort of passive, for example, chilled mat system, maybe attract more of a premium, partly because they're less typically used, partly because there's less available providers of those products in the market. But I would hope that that would kind of subside as perhaps that sort of system type becomes more typical. And at the end of the day, I feel like it's sort of a case of, your systems don't have to be enormously complicated if you can accept, or if you can persuade the market or your tenants to accept perhaps slightly less control over their heating and cooling temperatures. For example, you could provide a serviceable building that was low embodied and operational carbon without creating a very complicated or innovative service.
Rhona, I think you've frozen. We've actually run out of time now, so I think we better wrap up. I don't think, Matt, you didn't want to add anything, did you, Matt, here? So, I mean, it's been a really interesting session. Big topic. We're going to be talking about this a lot more, I think, going forward. And what's really interesting about the piece of work done by Arup and Alinea is that it does show that achieving net zero at low cost is possible. I mean, there's still a premium to be paid, but the costs are coming down, which is an extremely positive thing. And well, clearly, to get to that point where there's cost parity, there's still many challenges to resolve before it becomes business as normal. And as a whole, so there's a big question, such as practical issues, such as who's responsible for measuring carbon on projects and ensuring that the data is consistent and accurate. There are other challenges, including balancing net zero considerations against commercial pressures, such as deep basements and tall buildings and high land value areas. And of course, there are also the wider considerations, including balancing well-being against net zero. People like to be able to open the windows and don't like automated blinds which block out the light, but they might be more efficient. There are cultural changes as well, such as being much more relaxed about dress codes during hot weather, and also living without carbon-intensive materials such as carpet and suspended ceilings. The good news is that I think the development and the construction industries really want to resolve these challenges, moving in the right direction. So that's all from me. I'd just like to hand over to Stephen for the final word. Thank you, Stephen.
All right, thanks everybody. Thank you very much to all our speakers. Thanks very much to Thomas Lane from Building Magazine for chairing a fascinating session. Thank you all for your questions. I'm sorry we didn't get to all of them. There are lots and lots more great questions in the chat that we couldn't get to. As I said at the top of the session, this is the start of a series of Breakfast with Arup events exploring our journey to net zero carbon. So please do keep a lookout for the date of the next event, and we look forward to welcoming you all again soon. Thank you very much.